So DC color looks like this if you're curious. So on platforms where there's UI kit, it compatibility aliases to UI color, and on macOS, it is NS color. So if I don't know about you, but I've never seen compatibility alias like in Objective-C before until I ran into this bug. Like, has anyone in here actually used this before? No? 0 hands? So it's basically like type alias in Swift. So I was like, maybe we should post something on Swift Evolution and see if we should actually have Swift import compatibility alias as a type alias. So initially I was like kind of saying this jokingly because I read Swift Evolution, but I'm kind of a lurker. Like I just like subscribe and sometimes read, and I never thought about participating in it because it's kind of intimidating, and sometimes people get into super intense discussions about like access modifiers and stuff like that. So I was a little bit intimidated, but I said, okay, I'm gonna do it. I'm gonna. That was an appropriate slide. So I'm gonna do it. I'm gonna write to Swift Evolution and see what happens. So I did, and I wrote this up. I probably proofread it about 30 times because I was afraid of like how many people it was gonna get sent out to, because like it's probably like thousands of people, right? And I sent it out, and I was like, oh my god, like what am I getting myself into? I have zero idea what I'm doing. I'm a little bit scared what kinds of responses I'm gonna get. But I started getting responses, and most of them were supportive, like thumbs ups from people in the community. And then eventually I got a response from Doug Greger on the Swift team saying, hey, like that actually does make sense to map it to type alias, and it's probably something that doesn't need a proposal because it's like a bug fix. Thanks for bringing it up. I had no idea anyone knew about or used compatibility alias ... Doug. So cool. So that wasn't that bad. So I was like, okay, my job here is done. I submitted a bug report like a good citizen of the Swift community, and like I think most of my contribution day-to-day to Swift is mostly just submitting bugs and getting them fixed, but I'm not doing the fixing. I was like, okay, I'm done. It'll probably get fixed for Swift 3, and everything will be awesome. But then I checked my Twitter DMs, and I saw this message from one of the Swift engineers, Michael. He said, you should have stolen the bug yourself as a starter bug. If you act quick, maybe you still can. I was like, that's funny. Like, I'm just an iOS developer. Like, I write Swift code, but not that kind of Swift code. So I just thought it was a joke. But I saw another message. Seriously, do you want to fix it? At this point, I was like, how starter is this thing? Because I am as unfamiliar as one can be with the Swift code base, and like, I wasn't lying. Like, I'm totally intimidated, and I was trying to like slowly back away and get myself out of it. And that was kind of the beginning of my journey in contributing to Swift. I was very reluctant, and a bit of a spoiler, like I did end up contributing to Swift. And today I'd like to show you all the steps that I went through and share a little bit of that with you. All right, so before we get started, we have to make sure you don't need to write a proposal for whatever change you're making. And you also need to make sure no one's already working on it already. So what do you do that? So first of all, you want to check the mailing list, make sure no one's already talking about it. So I did a quick search. That was good. Then I emailed Swift Evolution, which was intimidating, but it was worth it. And then you eventually get a thumbs up from someone on the Swift team. And then you get assigned an SR. So what in the world is an SR? An SR is one of these Jira tickets on bugs.swift.org. So if you want to access this, all you need to do is go to bugs.swift.org and make an account. And if you want to get assigned to something, now you can. So you can see that, yay, I'm assigned to this thing. So that's cool. Like, now what? Well, at this point, like all the fears are like kind of like bubbling up in my mind. First of all, this is a completely new code base. It's huge. It's existed for 6 years now. Second of all, it's compiler code, and I have zero experience with compiler code. Actually, like one summer when I was interning at Google, I was actually like on like the C++ compiler optimization team, which sounds like really, really intense, right? But I was just writing JavaScript for them because I guess compiler engineers are kind of terrified of JavaScript code because it's such like a high-level thing, and they'd much rather write like assembly code or something. So compilers, terrifying. I was regretting not taking a compilers class in like the 4th year of university because like I was already taking machine learning, and I was like, I'll die if I take compilers. But I was regretting that. And last but not least, the entire code base is in C++, and I have 0 experience with that too. So given these things, I'm like, I still have no idea what's going on. Like, what did I get myself into? But if you think about it, like, when's the last time you felt like you had no idea what the hell is going on? Like, I think for me, like, besides this, I can think of like, maybe when Swift first came out, everything was confusing. Like, how do I make an initializer? I don't understand anything. Maybe before that was when I started like iOS development. Maybe before that was maybe in like high school physics class. Physics is pretty hard. And I don't remember much from my physics classes, but there are these 2 words that have stuck with me since high school. And it's proceed fearlessly. So my high school physics teacher, Dr. Weitz, every time we handed in our problem sets and we got the answers and solutions back, he would like kind of walk us through like all of like the crazy steps to like solve this crazy physics problem. And everywhere in the problem set, like it'd be like proceed fearlessly, just keep going. Like even if you have no idea what you're doing, just keep going. So this has kind of been like repeated in my head over and over again. So when I feel like I have no idea what's going on, I'm just gonna keep going, see what happens, see where it takes me. But it's easy to say like just like keep going, see what happens. So what can we do to make that a little bit easier so we don't like actually like die in the process of trying to contribute to Swift? Well, I think a good first thing to do that's optional is to find a mentor. So for me, my mentor was Robert from the Swift intern team. He was interning on the Swift team this summer, and Michael was kind enough to introduce me to him. So he's _Coda5 on Twitter. You should follow him. He tweets like really complicated things that I don't understand, but he's been really helpful in this entire process. And like now that I have like all this knowledge that I would have never gained on my own, I'm hoping that I can share what I learned from him and share it with everyone here. And I'm sure everyone is thinking like, well, how do I find a mentor? Like, not everyone can just like find like a Swift intern to help you. So, I mean, if you can't find anybody, I can kind of be your mentor. Like, I might not be as good as him, but I learned a lot from him. So that's that. And I'm hoping that if I can teach like at least a little over 1 person, and each person who learns from me can teach like a little bit over 1 person, like the community of people who know about the Swift compiler will just increase exponentially, and it'll be awesome. All right, so let's assume you found a mentor or you're stuck with me. The first thing you want to do is, of course, clone the repo. So this is pretty similar to like the normal way that you clone a repo with a few quirks. So you can just go to github.com/Swift. So the only difference between cloning a normal repo and Swift is you have to make a directory called whatever you want, but I'm going to call it Swift source because that's what they recommend. And then you have to cd into it and then clone it. Because what happens when you run that last update checkout clone is it pulls down a lot of other repos like in the same directory that you cloned it in. So if you don't make that upper level directory, it's going to dirty whatever directory you're in. So definitely do that. And so those are the first 3 steps. And the last step, according to Robert, is go read a book. And throughout this entire process of setting up Swift, you should totally pick a good book to read, because there are lots of steps that take a really long time, and this is one of them. So, pro tip. All right, so the next step is you want to get CMake and this tool called Ninja. So what are these things? So CMake is the thing that manages all of your build configurations, and Ninja is the thing that actually does the building. So we'll see these things in action later. So how do we get CMake in Ninja? So if you look at the README, it shows you like, okay, you can get CMake by doing all those things, and then Ninja by, you can build it from source. I don't know about you, but I don't like building things from source when I don't have to. If you like doing that sort of thing, be my guest. But for those of you who don't want to build things from source, there's a little section at the bottom that says you can install via third-party packaging tools. So instead of building stuff from source, you can just run brew install cmake ninja. So I highly recommend doing that. Just like skip over the stuff about building from source, because it's a lot easier. And if anyone has trouble setting up Homebrew, let me know, because I think I've run into like every possible issue with Homebrew, so I can probably help you out there. Cool. So now, this is where things get fun. We are going to build the project. To build the project, all you need to run is the build script. So once you do that, let's see. What does this do? So that will build everything and dump out an Xcode project in the build directory, and then I hope you picked a good book, because that also takes a while, and also kind of like heats up your computer, so if anyone's cold right now, you can pull up your laptop and just like run that build command. Yeah, it takes, I think it took me like multiple hours to do that at first, so fun stuff. That's why you need a good book. All right. Oh. So you end up with a Swift Xcode project in that directory. It looks something like this. Now things are getting real. Like, I'm sitting at my computer, I have Xcode open, and I have like the entire Swift source code in Xcode. And now it's time to implement the thing. Oh my god. Things are real now. And at this point, I'm like, I really have no idea what's going on. It was like hard enough to get the thing to build on my computer, and I was like pretty happy with myself for getting that done, but like the real work starts now, right? But like, even though I have no idea what's going on, honestly, like, what's the worst that can happen? And also, there's a lot of existing code in the Swift code base to use. Like 6 years of code sounds scary, but at the same time, that means that there's a lot of example code that we can use. Like, I don't know about you, but when I learned iOS development, how I learned it was I went through an iOS book full of examples from cover to cover, just like going through a bunch of example projects, and that's how I learned. So I think it's great that there's a lot of example code that's already in the Swift project. Yeah, and like I said, what's the worst that can happen? Like, if this type alias thing doesn't ship, like no one knew what it was, the compatibility alias thing anyway, so like even if it doesn't ship, oh well. So as a reminder, what we're trying to do right now is we want to import Objective-C's @compatibility alias as a type alias. All right, so how do we get started? Maybe a question that you want to ask is, what other Objective-C things are pulled into Swift? Oh. Where are the other Objective-C things pulled into Swift? And then the answer to that is import declaration.cpp, C++. So if you look there, I found this empty function here that's called visit obc compatible alias declaration, and it was returning a null pointer. Like, of course it wasn't like being imported as a type alias, right? It's just being completely ignored. So that's how I found like where I'm supposed to be rewriting this code. So that's a good start. And then to implement it, maybe the question that we need to ask is, what behaves similarly to @compatibility alias? And in other words, what also gets imported as a type alias? Can anyone think of something in Objective-C that gets imported as a type alias? Yeah, typedef. So with typedef, you can say something like typedef NSString string cheese, and then you can use string cheese everywhere instead of NSString. So from there, I did a lot of things that looked basically like this. So I knew what the input to the function was. I knew what the output was. I knew that it was similar to typedef. So I started with like the typedef implementation, copied it over, got rid of a few things, massaged some types so they get the types right. Like, I would go into more detail, but honestly, I think it's not that interesting because this is the part that's different for everyone who's going to be working on whatever bug fix or feature that they're working on, right? But I guess my point is, I went off of the example of type def, and because that was there, it made it a lot easier to implement this. So if you're working on a bug fix for Swift, you might want to think, like, where can I find something that's similar, that's already implemented, that I can start with, instead of like starting with like a completely blank slate, which is, I think, way too scary. And eventually, it builds, it compiles. Like until then, I was like trying to run it, and then types didn't match up, so it just like didn't compile at all, or whatever. So now it builds. Does that mean that we can ship it? Should we ship it? Yeah, no, you can't do that. And I heard some people say, tests? Yeah, we have to write tests. How do we know that this thing works? Maybe when you're doing iOS development, you can just like run the app and just like poke around and say that you tested it. But for Swift code, you actually have to write some tests otherwise. Like you can't just like open up an app and like see if it works. So let's see how we test Swift compiler code. So here's our plan. We're going to write some Objective-C code. We're going to import it from Swift. And then we're just going to make some assertions based on what we expect. So this is pretty like standard testing, right? So let's start with the first one. Let's write some Objective-C code. When's the last time you wrote Objective-C code? So I'm just going to import foundation, and I'm just going to write one line that's @compatibility alias string cheese and a string. That is it. I'm going to keep it as simple as possible for the test. And then I am going to put it in this directory, Swift test ID inputs custom modules. So everything, all the Swift tests are under Swift/test. And for some reason, all the importer stuff is under IDE. I don't know why. And then there's inputs custom modules, and it looks like that's where all the other test Objective-C files are, so I just put it in there. Again, I'm just going by example to see like how are other things that are similar like implemented or used. So that's that, and then, so that's done now. And let's import it from, I think I need to stand on this side. Let's import it from Swift. So I'm going to import compatibility alias. But how did I actually do that? Like, how did I import that Objective-C file as a module? Well, if you look in this directory again, there's that one little thing there that's called module.map. And if you open that, you'll notice that all the other Objective-C headers are exported as modules in this file. So what I did was I defined my own module map, basically just copied what the other things were doing, and then pasted it in right there at the bottom of the file. And we're set for that. And now let's write some Swift. So I just wrote a function that takes string cheese and outputs string cheese, and that's it. Keep it super simple. No need to make test code complicated. So that's done now. So what about that last step? Make some assertions based on what you would expect. So for that, we're going to be using something called lit-based testing. So lit is what the primary test suite for Swift is based on. So let's look at what lit tests look like. It looks something like this. Ooh. Oh man, when I first saw this, I was like, what is going on up here? I'm like, there. But, OK, this is a little bit intimidating, right? It makes XC tests look amazing. So let's break it down. Let's start from the bottom. So here's the code that we wrote earlier for Swift. And then up here, there's a print type alias string cheese equals and a string. So that is basically our like XCT assert. Or like this is the line that I expect to show up by importing this thing. So I want this Swift code to be like auto-generated. So yeah, it makes sense so far? Cool. So now let's look at the crazy mess at the top. So what is this thing? So what these run things do is you can just run like any like bash scripts with like some shortcuts for certain things that expand to directories or something that you use very often. And the thing is, like, you don't really need to understand what's happening, like, or you don't really need to understand all of what's happening. So how did I end up writing this crazy thing? Well, again, questions that I ask myself, what also links with an Objective-C module? And then in our case, it was Swift's new type. So I opened up Swift new type, and this is what it looks like. It looks very similar to what we saw earlier. So if you like go back and forth between, like, it's basically the same thing where I just changed new type obfc to compatibility alias, and that's like really it. So again, I based my implementation based on what already exists in the Swift code base. So that's how I wrote this test. I didn't write any of this by hand. So how do you run this test now? So now you know everything about lit testing. No, I'm kidding, but so how do you run the test? Well, for that, I went to the docs. So if you look at the README for Swift, there's a little section that says C docs testing RST. So I clicked on that. Oh. Went here, and then I scrolled down, and I started reading, and there's a little section that says, for day-to-day work on the Swift compiler, using this build script, ---- test should be sufficient. So I was like, great, that sounds exactly like what I'm supposed to run. But there's a problem. It took forever for some reason. I was like, I couldn't believe that anyone on the Swift team would tolerate such slow testing time. You write tests because you want fast feedback loops, right? But this was taking probably an hour or more. So I asked Robert, hey, is this thing supposed to take forever? And he goes, yeah, don't run that. It'll do a rebuild. But I looked at the README. So he says, if you want to just rebuild the thing to execute the compiler for something, I recommend running, let's see, cding into this directory, and then run ninja Swift. Ninja Swift, that sounds I don't know, Swift Ninja, we're hiring Swift ninjas. Anyway, that will just rebuild the compiler, and you can execute lit manually. Oh, great. I wish I had known that, because there's no way I would have figured this out on my own. And then you can run lit by running lit.py sv succinct verbose, and then this ninja debug assert Swift macOS 10 x86 64 test blah. And then you can filter and specify what test you want to run. Cool. So in our case, let's see, we cd run ninja Swift. We want to filter, but instead of my new test, we probably want to say compatibility alias. And I ran this, and of course, my tests failed, even though it was building. So good thing we wrote tests. So now what do we do? What do you do when your tests fail or when your app isn't working the way that you wanted it to? Fix it? How do you fix it, though? How do you figure out where the problem is? Yeah. All right, so how do you debug the Swift compiler? So for this, lucky for us, we are going to be using LLDB, something that we are probably already familiar with. So if you've used the debugger in Xcode, that's what you're using. So one wrinkle here is that when I was fixing this bug, for some reason, I think Xcode debugging was broken, so I had to do everything from the command line. And I don't know any other way besides doing it from the command line, so if anyone knows a better way, please write a blog post or something about it, because that would be awesome. So how do we do this? So when you run your tests with verbose mode on, so at least have -v, it outputs a lot of things here when you run your tests and your tests fail. So what's going on here is it's just telling you all the commands that the test script is running. So what you do is, first of all, let's see, you want to run Swift C through the LLDB and then pass in the parameters, so options. So I'm going to show you this in live, so don't worry if you don't understand what's going on here. So basically, we're going to run LLDB with this, and then once you're in LLDB, you're going to paste in all of this prefixed by R, which just means run. So R, and then everything starting from front-end target. So this is really crazy looking, so let's look at what it looks like in real life. So first of all, I changed my test, so it will definitely fail. I changed string cheese to blue cheese in my assertion, so that's going to make the test fail. And then once you're in Swift source, first of all, let's run lit. Okay, so failing tests 1. So let's see, it expected a string, type alias, expected string, not found in input. So the input was this. Intended match here. So it got string cheese, but it expected blue cheese. So that's how you read that. And if you scroll up here, there's this, let's see, one section that calls the Swift compiler. So let's run LDB and then this. And then I'm also going to go ahead and copy this entire blob starting from front end. So let's go into LDB. All right, so now we're in. So I'm going to type R and then paste that crazy thing in. Run it. OK, process exited with status 0. Great. So let's make sure it doesn't exit. How do we do that? We set a breakpoint. So I happen to know the exact line number of where I want a breakpoint. I mean, I'll just show you what that is. So 4096 in import declaration is right here. So it's going to do the equivalent of doing this. So if you set a breakpoint, and then if you run this again, this time it'll break, and it'll show you exactly where you are. So, and you can do like the familiar things like print name, and it says that it's a string cheese pointer. Cool, and you can do the same thing that you can do in Xcode. You can go next, next. You can do C to continue, and then it'll exit. Like all these commands, usually when I'm in Xcode, I do everything through the buttons usually, but it's kind of cool that I'm learning how to do everything through the command line, because I think when you have no idea what's going on like me, and you want to look cool, I think two of the best things that you can do is learn command line shortcuts and also just learn Xcode shortcuts, and you look like a pro. So benefits of learning how to use stuff in the command line. So that's the debugger. And eventually, actually before that, if you want to learn more things about LDB, their website has a lot of great resources. I didn't know how to set a breakpoint through the command line, but if you go here, it'll show you everything. It's awesome. Anyway, eventually, once you finish debugging, all your tests end up passing. And once you pass your tests, you can finally open a pull request. Thanks. Yeah, so I open a pull request. I guess if you say Swift CI, please smoke test and merge, it'll run all the smoke tests and it'll merge it automatically. And once it gets merged and you update your Swift version with the next release, you get to remove whatever hacks you had to do to get it to work without your bug fix. So even though this is only 2 lines of deleted code and it's doesn't seem that great in the grand scheme of things, it was pretty cool to think wait, I was able to delete these lines because of something in workflow because I was able to add something to the Swift compiler. So it was pretty rewarding to be able to do this. And I'm hoping that maybe some of you here might be also able to contribute to the Swift compiler as well. And if you're interested in learning more, there's a bunch of resources out there. Actually, not that many, but Slava wrote a really good blog post called The Secret Life of Types in Swift. And if you want to learn more about intense type and compiler stuff, I recommend that. I'm still not done reading through and understanding the entire thing because it's super dense, but it's awesome. Brian, aka Monocast, wrote a blog post about his experiences porting the Swift runtime to Android, and it's kind of a similar story that I went through. He's just step by step on how to do that. And then Jesse gave a talk at Try Swift Tokyo about his experiences contributing to Swift. And he does a really good job of outlining the different parts of the Swift codebase and the difficulty level of contributing to that certain section. So if you're interested, you should totally check it out. And then Russ Bishop gave a talk, I think at Realm, about contributing to Swift as well. So even though all these talks and blog posts are about like the same thing, like contributing to Swift, because Swift is less than a year old in terms of open sourceness, there aren't that many resources out there, and I think it's great that people are sharing their experiences, because each experience in contributing to Swift is going to be completely different, because it's a gigantic code base, and by the nature of contributing to like the compiler and fixing a bug, everything's going to be different for each person. And then maybe once you start contributing to Swift, maybe you can write a blog post or talk about it too, because there are not enough resources out there right now. You can't just like look on Stack Overflow and say like, hey, like, how do I debug the Swift compiler? Or how do I fix like this other thing that I don't understand at all? So yeah, and even if you're like, oh, I don't really care about contributing to the Swift compiler, I hope that the words from my physics teacher stick with you after this talk too, because when I was first learning iOS development, I couldn't even remember how to write like an initializer or a table view. And I think for table views, especially setting up like the data source and delegate, I would literally just go to the internet and like copy and paste table view, delegate, and data source code there, from like there to my code base. And like that was fine. Like it got the job done for what I wanted to do, and it's taken me where I am today in like the past 6 years. So if you ever feel like you have no idea what's going on, but you want to keep moving, just maybe you can just keep those words in mind. And yeah, that's it. Thank you.